Okay, so that was our first problem. Let's move on to W plus 7 is less than or equal to 4. So again, when we go to solve this, we're going to set up that t-chart. We had W plus 7. Opposite of plus 7 would be minus 7. Do that on both sides. My 7's here cancel. I'm left with W. Note that I just bring down whatever symbol is there for these adding and subtracting problems. So this becomes W less than or equal to negative 3. Again, I want to represent that with a number line, just with 3 numbers on there, negative 3 in the middle, negative 4, and negative 2. Now this time it's less than or equal to, meaning that I can include that value of negative 3, so I would have closed in circle. And if I have less than left, it means I'm shading to the left. Everything smaller than negative 3 would be to the left here. All right, let's go to the next one. So our last one with adding, so we have 12.5 is greater than or equal to D plus 10. Now, this problem is a little different since I have my variable on the right, but we're going to kind of see how that changes things or how it doesn't. So we're still going to just do our t-chart. We still evaluate our expression with our variable. If we had D plus 10, we're still going to do the opposite, which would be minus 10 on both sides. So I'll start on the left here. 12.5 minus 10 would be 2.5. Still bring down that symbol, greater than or equal to. And now D plus 10 minus 10, those 10s cancel. So now I have 2.5 is greater than or equal to D. Now here's where it gets a little tricky, because when we go to graph this, we see greater than. So we would think we're shading to the right. However, we're saying 2.5 is greater than D, which if I rewrite this with my variable on the left side, that would actually be D. Kind of reading it backwards here, D would now be less than or equal to 2.5. So whenever I have an inequality, I always want to make sure before I graph it, I move the variable over to the left side, because that's kind of how it's a little bit easier to graph. Now D is less than or equal to 2.5, and now it works like I would expect it to on the graph. Still doing 3 numbers, 2.5 in the middle. I can do 1.5 and 3.5. Again, closed in circle. And now we said it's less than, so I want to shade below here. So D is less than 2.5, or we could also read that as 2.5 is greater than D. So any value we choose for D, 2.5 would be greater than or equal to that. Are we good with adding and subtracting? All right, let's move on to multiplying and dividing. Did everybody get a chance to look at those notes already for today? If you didn't, that's all right. So adding and multiplying and dividing are very similar to adding and subtracting. When we do things like these first 2 problems that we're going to look at, n divided by 3 is less than 1 and 12k less than or equal to negative 24, it's going to work the same way as adding and subtracting, meaning that I perform these operations just like I would an equation. N divided by 3 is less than 1. Opposite of dividing would be multiplying by 3. So I now have n, these cancel, is less than 3. Real quick graph here. 2, 3, 4, open circle, and less than. Nice and easy, same thing we did up top. All right, next one. 12k is less than or equal to negative 24. Once again, we just do our normal t-chart. We had 12 times k. We're going to divide by 12 on both sides. So now k is less than or equal to negative 2. Less than or equal to means that at my negative 2, I'm going to do a filled in circle and again shade to the left. So far, nice and easy, right? Now, we are going to have something that's a little bit different here. So when you look at your notes, you'll see that there's 2 cases. Case 1 is when I multiply or divide by a positive number. Then case 2 is when I multiply or divide by a negative number. So here I have x divided by negative 3 is greater than negative 4. So I'm still going to start with my t-chart. I'm still going to think about my opposite of dividing by negative 3, which would be multiplying by negative 3. I'm going to do that on both sides. My 3's cancel. I'm left with x. I'm going to skip that symbol for now. Now I have -4 times -3. Well, we know a negative times a negative is a positive. But if you look what happened here, we went from a negative value to a positive value. Since our sign changed there, that means that my inequality symbol needs to flip around. So I no longer have greater than, I now have less than. So it's now the answer would be x is less than 12. And again, we do that because our sign of our number changed. When the sign of our number changed using multiplication division, we have to flip that symbol around. And that always happens when we multiply or divide by a negative. Let's graph that. Less than 12 is open circle 12, shaded to the left. All right, last one. -5z is less than 35. Again, normal t-chart. We had -5 times z, so we know we're dividing by -5. Divide by -5. 5's cancel. We have z. Then 35 divided by -5. We did have a positive 35. Our answer now is -7. So once again, that less than in the middle gets flipped around, and we now have z is greater than -7. Open circle, shaded to the right. So big takeaway from today, main idea I want you to remember for today. When you multiply or divide by a negative, right, flip the symbol. Ran out of room. So flip the symbol means if it was greater than, it becomes less than. If it was less than, it becomes greater than. And it works the same way for less than equal to, greater than equal to. Anytime you have an equation where you multiply or divide by a negative value, you need to flip around that inequality sign. Questions? All right, that was the main thing for today. That's what you saw in your notes. And then you'll practice that on the IXL. So IXL today is all 4 operations. It's going to be adding, subtracting, multiplying, and dividing all mixed together. And if you read the directions, it said I'm looking for a SMART score of at least 80. So once you get to that 80, you can stop. You can feel free to work up higher. When you receive 100, that's considered mastery in IXL. But it's up to you how far you want to go once you get to that 80. All right, I have 2 more problems for you, and those 2 problems are similar to what you're going to see tomorrow. So tomorrow we're going to continue working on one-step inequalities, but everything you look at tomorrow and Friday is going to be a word problem. So I'm going to post notes for you for tomorrow to look over, copy down, practice with me. Also post a video to go with that. And then tomorrow your assignment is again going to be IXL, doing one-step word problem inequalities. That's going to be a little bit trickier than what you did today. So because of that, I'm giving you 2 days to work on that. So actually your IXL for tomorrow is actually due on Friday. So you'll have 2 days to achieve that SMART score of 80 for the word problems. All right? But I'll post that on Google Classroom, so you don't have to worry about that right now. All right, on my screen, which you can see, correct? Yep, okay. On my screen, it says a small airplane can hold 44 passengers. 15 passengers board the plane. Write and solve an inequality that represents the additional number of passengers that can board the plane. Can 30 more passengers board the plane? All right, so when I have a word problem like this, first thing I'm looking for is my total. What is my number that I can have at least, at most, fewer than, greater than? And for this one, it's like total number of passengers on the plane. So my plane can hold 44 passengers. So I can't have more than that on there. So I know my number of people has to be less than or equal to 44. I can put 44 on there, but I can't put 45, 46, or anything greater. So my number of passengers is less than or equal to 44. All right, what do we have? Well, we already have 15 people on there, and we want to find out how many more. So to represent that with an equation, first I need a variable. So x is going to be my number of people. And if I already have 15, I want to know how many more. Representing that with an equation, I would say x plus 15 is less than or equal to 44, meaning that the number of people I add on here has to be less than or equal to 44. I don't need to fill the plane to capacity. I can have less than 44, so that's why we need that inequality there. So if I want to find out how many more people can board the plane, I'm going to just take this and solve this just like we did with our last problems. So start with my t-chart. I have x plus 15. I'm going to subtract 15 on both sides. I'm left with x here when my 15s cancel out. I did not multiply or divide by a negative, so my sign stays the same. And if I do 44 minus 15, I'm left with 29, meaning that I can have less than or equal to 29 more people on the plane. So the question is, can 30 more passengers board the plane? Well, that's kind of like checking if this is a solution to this inequality, which is something we did in the notes for today. I said, is some number a solution to that inequality? That's what I'm saying here. Is 30 a solution to this inequality? So if I have x is less than or equal to 29, if I plug in 30 there, is this a true statement? Is 30 less than or equal to 29? Is 30 less than 29? No, it's definitely not. So we would say no, not a solution. 30 would not work. So we cannot have 30 more people board the plane. We can only have 29 or less more people board the plane. Okay. All right, last problem for today then says smartphone. You earn $9.20 per hour at your summer job. Write and solve an inequality that represents the number of hours you need to work in order to buy a smartphone that costs $2.99. All right, so if we see per hour, whenever you see per something, it tells me I'm multiplying. So if it's per hour, I know X is my number of hours. Also, my question was how many hours do I need to work? So I'm going to start by establishing the X value as X equals number of hours. Well, if I make $9.20 during each of those hours, I'm going to do $9.20 times that X value. And now this one I started a little different than the last one. Last one I started with my total. Here I'm ending with my total. I know I need to earn $299. Now that's not always going to work out to an exact number. We're not going to work exactly enough hours to work at $299. So again, that's why this becomes an inequality. Because I don't need exactly $299. I need to earn more than $299. So the amount that I make, my $9.20 times my number of hours, needs to be greater than $299. If I have less than $299, I can't buy this. If I have exactly $299, I can. So we're going to put that as 920x is greater than or equal to $299, meaning that I can earn exactly that amount or more than that amount, and I'll have enough money to buy my smartphone. Let's solve it. Find out how many hours I actually need to work. So I had 920x is greater than $299, so I'm going to divide here by $9.20. So once again, my 920s cancel, and I'm left with just that x is greater than or equal to, because I did divide by a positive value. And when I do 299 divided by 920, I get 32.5, meaning I need to work 32.5 hours to earn enough money. But again, we have this as an inequality because you can't always work a half of an hour. So it could be working 33 hours to give you enough money to buy that phone. But we know we need at least that 32.5 hours will give you exactly enough.